Hey y'all. Today's objective is slope-intercept interpretation.
Alright, so today in class we reviewed the formula for slope-intercept form, which is y equals mx plus b. M is your slope and b is your y-intercept. And just as a review, before we talked about recursive and explicit functions, your slope-intercept form is your explicit function. You can replace the y and the x with input and output. Remember that slope is the rate of change and y-intercept is the starting amount or your initial value.
And the y-intercept is on the coordinate plane where it crosses the y-axis. So any point where it crosses the y-axis. It could be at the origin, it could be above, or it could be below.
Alright, so the example that we really want to talk about today is understanding what's happening if you have a table or a graph and being able to describe it in a real world situation. So we have an input-output table. Remember, input again is your x value and output is your y.
Also, input is your independent variable and output is your dependent variable.
That's right. So the first question asks you, it goes through a series of questions, find the rate of change. So you have to remember that the rate of change is simply your slope. So you can do one or two things. If you have a table, you probably need to use your slope formula, y2 minus y1 over x2 minus x1. So we're going to find the difference in two of the points. You pick 2 points on your table. So what is 8 minus 4.5? 3.5. And then you're going to do 4 minus 3, which is 1. So remember, slope is the dependent over the independent. So our rate of change is 3.5. Alright, 3.5 over 1, which is just 3.5.
And you could use this point, 4 and 8, and you could have used 2 and 1. So 8 minus 1 is 7. 4 minus 2 is 2, and you still get 3.5. So you don't just have to always use these 2 points. You could use any of the points, and you're going to come up with the same slope.
Yes. Now the y-intercept, we talked about this earlier today in class when we introduced slope-intercept, is the y value when x equals 0. So in this particular table, we know this value. So the y value is -6. So our b in this table would be -6. And of course, that is our m. Once you know m and b, just like we did in class, you can write the equation in slope-intercept form. So you have y equals 3.5x minus 6. Well, -6 is your starting amount, and it's increasing 3.5 over 1 to get to the next point. Now, this is the part that's new, going from your explicit to your recursive. Recursive, again, is your now next equation. So, it's going to be next equals. Now, this is how much it's changing every time. We're adding 3.5 to get to the next number every time. So plus 3.5, and we talked about this earlier in the year, it's repeated addition. Multiplication means repeated addition. So this is what you're adding every time to get to the next number. But you're starting at -6. So that's how you would write. This would be what you're adding every time, and this b is your starting amount.
So this kind of bridges together what we did last unit with recursive equations, explicit equations, and now putting it all together into input-output. So example 2, we have another table, and we still need to find the rate of change or the slope. So whenever you're given a table, you would use the slope formula. So you could pick any 2 points. We'll just pick these 2 points, and you would subtract 21 minus 0 and 35 minus 20. You would get 21 over 15. And then you can reduce, since it's a fraction, we can divide both sides divide the top and the bottom by 3, and we get 7 over 5. So my slope is going to be 7/5, which means you would rise 7, run 5. Rise over run. The y-intercept, when you look at this chart, we do not have a 0 in our x column. The y-intercept is when x is 0, when you're starting the initial amount, or when x is 0 for your initial amount. If that's not the case, we have to figure out what the y-intercept is. And you just learned a skill to find a missing coordinate knowing the slope. So let's review that quickly. We know the slope is 7/5, and we want to use a point. Doesn't matter. Which point should we use?
Let's stick to
This
0,
one.
20.
So we're going to use the point 20, 0, and we need the y-intercept. So the y-intercept is when x is 0 and we're looking for y. So remember, given 2 coordinates in the slope, finding the missing y. And we know the slope is 7/5. So we're going to set up the equation. We know it's going to equal 7/5. So y minus y is y minus 0. X minus x, 0 minus 20 is going to be negative 20. And we don't really need this y minus 0, so I can do away with that. And we have to use the cross product.
So you end up with 5y equals negative 140.
Solve that for y, divide both sides by 5. And y equals negative 28.
So this is what y is when x equals 0. So remember, we just talked about that is your starting amount or your y-intercept. So that means our b is negative 28. So then we should be able to write our y equals mx plus b equation now. It will be y equals 7/5 x minus 28. Now remember, going from your now to your now next equation, if you know the explicit, should be simple. It's next equals now. This is positive, so plus 7/5 every time, starting at negative 28.
And notice in your chart, right here would be the x value of 0, and it doesn't give you the y value, but we found it using this skill. It would be negative 28. And that would make sense because as our x's are decreasing, our y's are also decreasing. And so that would make sense. If you got a positive 28, then that would kind of look funny if all of a sudden you had a positive right here. So that is a good sign.
Alright, so the next one we want to actually look at graphs and do the same thing. You should be able to go back and forth between the equation, the graph, and the table. So in this particular case, we have rent for a carousel, where our independent variable is hours and our dependent variable is the rental cost. So we have the graph drawn for us already. The first thing is find the rate of change and describe what it means. So if you have a graph to find rate of change, remember you're going to do rise over run. So Ms. Hamlet's going to pick 2 points. She's going to count up and over.
So I just picked the first 2 points. You can pick any of them, but I picked the first 2. So when I rise, I go up 1, positive 1 direction, and I run over 1. Is it 1 over 1? And then to check it, you could do the same thing. Up 1 over 1, up 1 over 1. So the rise and run is 1 over 1. So when it says describe what that means, you can't just say the slope is 1. Because 1 divided by 1 is 1. But what does that mean in context? This is your dependent and this is your independent.
So what it means is that the cost increases, because it's positive, $1 every 1 hour. So you're taking the description of the independent and dependent variable and describing your fraction for slope. All right, the next thing is find the b. Describe what that means.
So where it crosses the y-axis is this value right here, which is 0, 0. Remember, the y-intercept is when x is 0, and then this example is 0, 0, the origin. What that means in this context is if you rent the carousel 0 for 0 hours, you're going to pay $0. So at 0 hours, it costs us $0.
Alright, so this is the more important part. Last year you guys focused on just finding the y-intercept and just finding the slope. This year we need you to be able to describe in context what's happening when you find those two. So these are two good examples. Now we want to write our equation in y equals mx plus b. That's simply going to be y equals x. We don't need to write plus 0, and we don't write a 1 in front of a variable. So your now next equation would be next equals, now every time we're multiplying by 1, so we're adding 1 every time, and we're starting at, what, Miss Handler?
Starting at 0, because that is our
Initial
initial value, that is our y-intercept, that is our b value.
Alright, so hopefully you have taken notes, and we will go over some more problems tomorrow in class.